All right. See how we're looking. All right. We are back live. Let's do this. Now the question is, what should we do? What should we do? Well, let's come up with a question for Instagram first, because we haven't got any requests. And let's double check. Yep, no requests. Some new followers, but no requests on Instagram. So, what should we do? Let's see. Integration by partial fractions? Maybe, so partial fractions, that'd be something we could do. Let's think about, how do you get a partial fraction in the first place? Ooh, a long division one to start? Maybe, okay. Long division one. You know what? I'm going to turn on some tunes for myself. I suggest you do the same. Okay. Yeah, let's do this one. Okay. So technically we're going to integrate x to the 4th minus 2x squared plus 4x plus 1 over x cubed minus x squared minus x plus 1, and of course with respect to x, dx. Let's do division first. So we've got x to the 4th minus 2x, all this stuff, and it's being divided by x cubed minus 2 minus x squared, blah blah blah, and we need to do long division. And if we remember our long division from like, when did we do long division? Elementary school? We usually set it up just like this. And then what we do is we figure out what do we multiply, what do we have on the top that multiplies down to give us something that'll cancel out. Well, an x here will work, right? So then x times x cubed is x to the fourth, and minus x cubed. And you know what? To do this a little better, I'm going to rewrite this and leave a space for a placeholder. So technically we would have plus 0 x cubed. Then we have minus 2x squared plus 4x plus 1. See why I did that now. Okay. And then x times minus x, which it would be minus x squared, and x plus 1 is just x. And now you'll subtract the second row from the first row, which this will cancel out and give us 0, and this will give us a plus x cubed, and minus 2 plus 1 is minus 1 x squared. 4 minus 1 is 3, and then we'll bring the 1 down. And now we will add 1, because 1 times x cubed gives us x cubed. And then we've got a minus x squared. And we've got a minus x. And a plus 1, right? And now we're going to subtract. This will cancel out. This will 0. This one will cancel out. 1 plus 1. 1 minus 1 is 0. And then this will be a 4x, right? There's our remainder. Now, maybe for our Instagram post, maybe we'll just do a division question for a remainder. Be an okay post. Oh, we'll see. We'll see. And then, so what do we have? We've got an x plus 1. Plus 1. And then we've got a plus 4x. And now this is being divided by the x cubed minus x squared minus x plus 1. We've got x cubed minus x squared minus x plus 1. Okay, okay. So our integral, and now we're doing this integral with respect to r. Now we have to factor this denominator, because this is still really confusing. So let's figure out how we can factor this. Well, x cubed minus x squared minus x plus 1. Just by looking, we can see that 1 is a factor. It would be 0. So if we plugged in a 1, we get 1 minus 1 minus 1 plus 1 equals 0. 1 is a factor. Okay, so x plus, or is it x minus 1 is a factor. And then we're going to multiply by that onto something to give us our x cubed. So that'll be some kind of x squared. And let's see. Minus x squared. Here, I'm going to get rid of this line because it doesn't matter anymore. Make it a little neater. Okay, okay. x squared, and let's see, x times x squared. Here we go, x times 1. We need a minus 1 at the end there to give us our plus 1 at the end. X times x squared minus x squared plus 1. There we go. Ah, that was an easy one. Minus 1. Okay. X squared minus 1. Well, that's a difference of squares. We got x minus 1 times x minus 1 times x plus 1. Difference of squares. Okay. Now what? So we've got, this is a square factor. There's two of them. So then we need to have a partial fraction decomposition with all of this. I'm coming down, coming down. So now we are down to the integral of x plus 1. And then this is, we're going to write this again. We got 4x over x minus 1 squared times x plus 1 dx. And now we're going to do partial fractions. And we're going to take the this component right in here, and we're going to split it up. So 4x over x minus 1 squared x plus 1 is equal to, we've got some number a over x minus 1 plus some number b over x minus 1 squared, and then plus some number c over x plus 1. Whoa! Now by trying to go in reverse, so making trying to make this, instead of separate fractions and put them all into one simple fraction, that's when we use the lowest common denominator to multiply out and see what we get. So this would be a times, well, what is it missing? It's missing one of the x minus 1s and an x plus 1. Plus b times, and what is it missing? Well, it's just missing an x plus 1. And c, and what is c missing? C is missing these x minus 1 squared. Okay. And all of this, when you multiply it all out and solve, should just equal 4x. Which is fine, I guess. It's not that big of a deal. So let's multiply it out. X times x is x squared, and plus x minus x cancel out, so we've got x squared minus 1 plus, I'm gonna just write this out, bx plus b, and then x minus 1 squared plus c times x squared minus 2x plus 1. Write it all out again. We've got a x squared minus a, because you'll distribute it. Then we've got plus bx plus b. And we've got plus c times x squared, because we're distributing the c, minus 2cx plus c. All of this added together has to equal 4x. So what that means is all the things acting on x squared, when you add them all up, they have to be 0. So 0 has to be, well, an a. plus c. And then, well, what about the single x's? Well, 4x has to be equal to b, this one, and plus minus 2c. And then the last one would be our constant. There is no constant over here, so we've got 0 again, is minus a plus b and plus c. Okay. Now we've got 3 equations with 3 unknowns. We should be able to solve it all. Okay, let's bring it down. Bring it down. Down to there. That'll work. So we could go a is minus c. Done. If a is minus c, we can look at this last equation here. So 0 equals the negative of a, but a is minus c, plus b, plus c. Okay, so then we'd have 2c, 0 equals 2c plus b, so b is equal to negative 2c. Okay, let's use that in this second equation. So we've got 4 is equal to b, which is negative 2c minus 2c. Well, we've got 4 equals minus 4c, so c equals negative 1. Okay, nice. If c is negative 1, well then a is the negative of c, so the negative of c would be 1, and b would be 2. A is 1, b is 2, c is negative 1. Done! Okay. Now we can split up our original integral into its partial fractions. Okay. So, there's a lot of work in this one. Integral of x plus 1 plus a, which is a 1 over x minus 1, plus b, which is 2, x minus 1 squared, and c, which is minus 1, so minus 1 x plus 1 dx. Now I'm going to draw a little box over here so that this is separate work. Okay. Okay. So now we can integrate. What is our integrals? Well, the integral of x is x squared over 2. That's just the power rule. And the integral of 1, which is just a constant, is x. Then we've got the integral of x minus 1, which is the natural log. Okay, so this will be the natural log of x minus 1. The integral of 2 over x minus 1 quantity squared. If you remember the power rule, basically, this is just 2 times x to the minus 1 to the negative 2. So if we go in the opposite order, and let's say we add an exponent, we've got a negative 1. So that still works. And we might have to multiply by a negative. We'd have negative 2 over x minus 1. What's the next one? Well, we've got minus the natural log of x plus 1 this time. And of course, you've got plus some constant. Plus c. Okay. That's our integral. We still got one thing we could do, make it a little nice. We're going to rewrite it slightly. We've got x squared over 2. We've got plus x. These natural logs can go together. I'm going to write this negative 2 over x minus 1 first. And then I'm going to add, well, a difference of natural logs is just the natural log of the first one divided by the second one. So this turns into the natural log of x minus 1 over x plus 1 plus some constant. Boom! Now I did that really fast. Primarily because I knew what I was doing. And this seemed like a really complicated question to start with if you were doing your first set of partial fractions. Really, what I'm doing is just trying to find one that I can put in for an Instagram post. And practice, as always. So what else can we do? Is there any easier ones? Well, this one seems pretty easy. Maybe we'll do this one instead. We've got the integral from 2 to 3 of 1 over x squared minus 1. Okay. What should we do? Well, we will do it's split up. X squared minus 1 is the difference of squares. X squared minus 1 is equal to x plus 1 times x minus 1. Yep. Okay. Then this integral from 2 to 3 is going to be split up to 1 over x plus 1 times x minus 1 dx. We want that into some partial fractions. 2 to 3. We've got a over x plus 1 plus b over x minus 1. And dx. And so if we were to go in reverse to try and figure out what the value of a and b is, we gotta find a, well, what it's missing is the x minus 1. And b is missing the x plus 1. And what is it equal to on the left-hand side? There's literally just a 1. There's no value of x. So what is this? Ax minus a and plus bx plus b. So there's no value of x, so 0 is a plus b, and 1 equals minus a plus b. And in this one, we say b is equal to minus a. Take the a to the other side, whatever. Then, in this one, well, if b is minus a, we've got 1 equals minus a minus a. So 1 equals minus 2a. Divided by minus 2, we've got negative 1/2 is equal to a, and which implies that b is equal to 1/2. Nice. Okay. Now, what do we do? We've got these values, so this integral, we'll write it over here. Should have moved that over a bit, but whatever. Integral from 2 to 3, a, which is minus 1/2. I'm going to write a minus 1 over 2 times x plus 1. You know what? For simpler sake, I'm going to write it as a constant in front. Minus 1/2 times 1 over x plus 1. And then b is 1/2, so plus 1/2 times 1 over x minus 1 dx. Okay, now what do? We changed it. We can integrate. Well, like we did in this previous question, right here, these ones are natural logs. We'll do the natural logs. Okay, so we've got the minus 1/2's in front. We'll leave it in front. Natural log of x plus 1. And then plus 1/2 natural log of x minus 1. And of course, plus some constant. Now, let's simplify this a bit. Let's take out a 1/2. We've got 1/2 out. And we've got natural, I'm going to change the order so it just looks prettier. X minus 1 minus the natural log of x plus 1 and plus some constant. Then we're going to do the logarithm rule. So this is a difference. So then this equals 1/2 times the natural log of x minus 1 divided by x plus 1 plus c. Now that one wasn't too bad. And of course now we will plug in our values. We got from 2 to 3. So I'm going to erase this constant now. From 2 to 3. And I'm going to write it over here. This will be a little bit nicer. We've got 1/2 natural log 3 minus 1 over 3 plus 1 minus 1/2 natural log of 2 minus 1 over 2 plus 1, which equals, well, 1/2 times, well, 3 minus 1 is 2, 2 over 4, so natural log of 1/2 minus 1/2 times the natural log of, well, 2 minus 1 is 1, 1 over 3. Okay, well now we've got a difference again. Now, I wonder, would that be acceptable left that way, or should we have it as whole numbers inside our natural log? Let's see what they wanted as an answer in their book. What question? 7.411. So I'm using a textbook that I actually had to use in first year. What am I doing? 7.411? Yeah, okay. So they wanted to completely split up again. What does this equal? 1/2. This is the division, right? So this is the natural log of 1 minus the natural log of 2, right? And then we've got minus 1/2 natural log of 1 minus the natural log of 3. Okay. Because we're using the logarithm rules. Log of a over b equals log of, I'll just say ln of a minus ln of b. When we also have, we notice that ln of 1 is 0. Because e to the 0 is 1. So then we've got 1/2 minus 1/2 ln 2. And this one is 0 as well. 0 plus 1/2 ln of 3. Because there's a minus times a minus. Then we'll take out the 1/2 again. 1/2. And we notice that we've got ln of 3 minus ln of 2. So we've got natural log of 3 over 2. This is our answer. It's a little bit lengthy, even though, I mean, we start here. Maybe we should just do a partial fraction practice one. Yeah. We'll do this one. So what did we start with? We'll do 1 over x squared minus 1. If this equals a over x minus 1 plus b over x plus 1, maybe we should do it in the smaller one, because this is really easy to write in. But I won't do it in the yellow post-it note. I'll take away that. We'll do it just in the black. We've got 1 over, well, let's make it a bit bigger. One over x squared minus 1 equals a over x plus 1 plus b over x minus 1. What are the values of a and b? This is a quick, easy one to post. Maybe I'll write it in text. Yeah. We'll have to drop the size a bit, of course. Oops. No, it didn't take it all. Yeah, that would explain why. $16, $18. Okay. And then bonus, what's the integral? Nah. What is this? 13? See, I'm kind of skeptical about post-it notes now because it looks kind of funny, you know? Anyways, that's done. Let's get that posted. I have to email it to myself, unfortunately. Why is this thing changing and making it so annoying? Okay. Well, we can't have this just readily available. Let's go back to the first question. So that I can post this without being so lame. Okay. Yeah, I look much younger than you thought. Well, that's because I have a baby face, bud. Baby face. Always have. Did you know if I shave, I get ID'd everywhere I go? It's true. I am just posting this. Hey, bud, do you have homework that you want to do? Because we can do it. Tutoring, streaming live. I wonder if there's a hashtag I'm bad at math. Let's go with that. Well, what do you got? Let's do some stuff now. Just send me a picture. And then I'll go through some concepts. I might as well work on something. At least semi-relevant. And if you pay attention, you pay attention. If you don't, go ahead. I might as well work on something worthwhile. Otherwise, I'm just going to go through and do random calculus stuff. And nobody likes random calculus. How did your friend do afterwards? Did your friend figure out how to do absolute values? Okay, partial fractions was good for a post-it note. What about after that? Continuity. Derivatives? Guess I could turn on the light now, hey? So I can see a bit better. Derivative as a function? Oh, you know what? I'm going to play with some derivatives. Derivative of sine is cos. So let's do the limit. I think it looks a little better if I use a bigger thing. As x approaches h. So this is the definition. X plus h minus f of x over h. We are going to do the derivative d by dx of sine. Okay. Now I haven't done these in a long time, so I'm not even sure if I remember all the tricks. It's not that hard, but we'll figure it out. We've got, so the limit is x approaches h of sine of x plus h minus sine of x over h. Okay. She actually understood it? Good. That's what I was hoping. Okay. Now, sine of x plus h. So there is a identity. Sine of x plus y is equal to sine x cos y plus cos x sine y. So let's play with that first. Well, then we've got the limit as x approaches h. Well, this turns into sine x cos of h plus cos of x sine of y. So this will be sine of h. We've got minus sine x over h. Now, I'm wondering, what do we do next? Do we use a double angle identity? Or we'll try this. And if it doesn't work, we'll try something else. We got a sine x over here. Maybe we'll try taking out a sine x. Well, there's another thing as well. Sine of theta is approximately equal to theta when theta is very, very close to 0. So very, very small. Or when it gets closer to 0, sine theta is approximately equal to theta. Oh, why did I write x goes to h? That's the other one. H approaches 0. Jeez. You guys didn't even catch that on me. Doing two different formulas at once in my head, I guess. Cosine of h. Cosine of h minus 1. And we've got plus cosine of x sine h over h. Now, this is interesting. If we take the limit, what do we get? There's a missing step in here. I know there is. And I can't think of it off the top of my head. Maybe it's written in here. May not be. Probably not. Let's quickly look and see. Yep. Exactly what I was thinking. Okay. So if we take out the sine x, this will be the limit I should write it this way. Limit h goes to 0 of cosine of h minus 1 over h, and then plus cosine of x limit h approaches 0 of sine of h, and this one will be over h. And we know that this, from earlier times, this is equal to 1. And then, so that would leave us with our cos x. Now, what about the cosine of h minus 1 over h? Well, this gives us 0 over 0, indeterminate method. But if we think about it before, this actually approaches 0. So this whole thing approaches 0, which leaves us with just cosine of x. Which is what I thought, but I forgot about just splitting it up and just doing it. I thought there was another thing. But that's okay. Okay, what else can we do? We did the definition of derivative with the exponents. Definition. Do we just do like derivatives? Derivatives are pretty simple. Let's see what we can get with funky ones. I'm going to drop this down a bit. Well, x squared sine x is a simple derivative. That's just using the product rule, right? Product rule. And it uses a trig one and power rule. Those aren't too difficult. So let's work on it. Product rule is derivative of fg is, what is it? Fg prime plus gf prime. Is that how they actually write it? I always mix up the product rule. Fg prime? Yeah, it is. Sweet. Because the quotient rule is opposite. So, if x squared is our f, sine x is our g, then we just need f, which is x squared. G prime, derivative of sine is cos. You just went through that. And then we have g plus sine x. And the derivative of f, which is, using the power rule, 2x. So this equals, well, we'll take out an x. And then we'll have x cos x plus 2 sine x. Easy, easy, easy. What about another derivative? How about x squared sine x cos x? This uses 3 functions. However, interesting thing here. You can do derivatives of 3 functions. You just need to have an extended product rule. But what I'm looking at is this sine x cos x is, there's an identity here. Sine x cos x, there is a double angle identity for sine 2x equals 2 sine x cosine of x. Okay, which means that if we just divide by 2, sine x cos x is just sine of 2x over 2. So then this derivative just becomes x squared times sine of 2x over 2. Whoa! And that looks pretty similar to this previous one, doesn't it? Very nice, very nice. So let's do the derivative. X squared will be our f. And we'll say, well, the 2 doesn't really affect the derivative too much. So we'll just leave it out front. So 1/2. And then our g is sine of 2x. Okay. Let's do the derivative of this now. So what was it? Product rule fg prime equals fg prime plus gf prime. Okay, okay. Which means f, which is x squared. We're going to leave the 1/2 there. X squared. And then g prime. Well, the derivative of sine 2x would be 2 sine x, or cos x, of 2x And then plus g. G is sine 2x. And over 2. And f prime, derivative of x squared, is 2x. Oh, look at this. 2 cancels there. This 2 cancels there. We are left with x squared cosine of 2x plus x sine of 2x. Well, Jiminy Crickets, man. That doesn't look too difficult. It's pretty much the exact same. This is actually just a coincidence that it looks pretty similar. And I did it kind of on purpose because of this. Okay, what other things can we do? Someone already commented on our post. No likes, but there is somebody who commented. Nice. Okay. Well, that was fun. Now let's actually do something. Derivatives of trigonometric functions. I mean, let's do this one. Okay. Find an equation of the tangent line to the curve to the curve y equals 2x sine x at the point pi over 2 comma pi. Now, it seems kind of difficult to just as a one-off, but it's probably not that bad. Equation of the tangent line to the curve. Well, what's the slope of the tangent line to the curve at that point? Well, we know the derivative gives the slope of the tangent line, so we'll do the derivative first. Y prime equals, well, we've got 2x sine x, the derivative of. Well, this is product rule again. So f g prime is f g prime plus g f prime. 2x will be our f, g will be our sine. Okay. F is 2x, so we bring that down just the same. G prime derivative sine is cosine. And then plus g, which is sine x. And f prime, well, derivative of 2x is just 2. We'll just do that. So y prime equals, I'll leave the 2 as in there. Now I'll take them out. 2 x cos x plus sine x. And we'll plug in the point. So when we look at the points, so that's our x and that's our y, right? So the value, so cos of pi is -1, sine of pi is 0. So y prime of pi over 2 is 2. X is pi over 2. And cos of pi over 2. Oh, yeah, we're doing pi over 2. What is wrong with me? Sine of pi over 2. So two we'll cancel out, but we'll do the cos of pi over 2. Cos of pi over 2, we remember the unit circle, and cos would be like our x-axis. Sine x would be like our y-axis. Pi over 2 is up here, which is like our 90 degrees. So cos of pi over 2 is 0. And sine of pi over 2, which is at this point, is at its peak. That would equal 1. So we've got 2 times pi over 2 times 0 plus 1, which just gives us 2. The y prime of pi over 2 is 2. Slope of the tangent line at that point is 2. Now, we need to find the equation of the tangent line to the curve. So, how would we do that? Let's think about it. Actually, I'll let you think about it. You think about it for a second. I'm gonna grab some. Okay. Well, equation of the tangent line. So remember that a line equation is what? Y minus y0 equals our slope m times x minus x0. I think that's how you write it. Yeah, that's how you write it. Okay, so then y minus, well, y0 is pi equals 2 times x minus x0, which is pi over 2. Go down a bit. And we've got y. We'll take the pi to the other side. We've got 2x minus pi plus pi. So y equals 2x. And this is our equation of the tangent line. Okay. Let's do another. Some limits. Well, here's an interesting one. Okay. When does this function x plus 2 sine x, when does this function have a horizontal tangent? Okay. When does this have a horizontal tangent? First, let's find a derivative. So that'll give us the slope of a tangent line. So f prime of x. Well, derivative of x is, well, it's just 1. Derivative of sine is cos, so plus 2 cosine of x. Now, when does it have a horizontal tangent? What is a horizontal tangent? So if we've got, let's say, a function that looks like this, which is pretty common. A horizontal tangent is when it goes straight across. Right? And what is the slope of a horizontal tangent? Well, remember, the slope of a line is rise over run. So it's not rising, so the rise would be 0. And the run, say, is any number, really. So 1. And which gives us 0. So 0 slope. So we'd go 0 equals to 1 plus 2 cosine of x. Because that's when the slope is a horizontal tangent. So we've got -1 equals 2 cosine of x. Divide by 2, so cosine of x is equal to -1 over 2. So x is the inverse cos of -1 over 2. When is that? Well, when is cosine -1 over 2? Do we use our circle? We should. Let me open it up here. Drawing the unit circle was probably the best idea. Okay. When is cos 1 over 2? That pi over 3. Right over here. So then we want -1/2. So when will it be -1? Right there. 90 degrees. 5 pi over 6. Want to double check? Let's see. 5 times pi divided by 6 is 2.617999. Okay. Cos inverse of -1/2 is 2.094. It was 2 pi divided by 3? Yeah, 2 pi over Okay. This, actually, it would be easier with this in a chart instead. Two pi over 3. Okay. Now, technically, there is more solutions. That's one of them. Now, if we add 2 pi times some number n, where n is in the integers, 1, 2, 3, blah, blah, blah. Well, we'll have 0 as well. Natural numbers. Then this will work for all of it. And of course, you could go plus or minus. Because if it goes down, then it'll also give you the same answer. What other stuff should we do? Ah, this one's cool. Okay, so we're talking about trig functions and derivatives. So we know that tan x is sine over cos, right? What about derivative of tan and the derivative of this? So what if we want d by dx of tan x? What do we do? Well, what's the derivative of tan? Well, we'll use our nifty reference guide. Derivative of tan is secant squared. So secant squared. And now this is a quotient. So what is our quotient? F over g prime is equal to gf prime minus fg prime over g squared. So in this case, f is sine and cosine is our g. So g is cos x. Derivative of sine is cos. So we've got cosine of x again. And we got minus f, which is what? F is sine x. Derivative of g, so cosine. What's the derivative of cosine? Derivative of cosine is minus sine. So minus sine all over g squared. So cosine of cosine squared. Well, if you look, secant squared then equals cosine squared plus sine squared over cos squared. Funny enough, cosine squared plus sine squared equals 1. 1 over cosine squared. Well, remember, 1 over cosine is secant, so it's secant squared. And look at that. if this becomes 1 and 1 over cosine squared, so we've got secant squared equals secant squared. What else can we do? What's another way we could write this? Instead of going straight into secant squared equals secant squared, another identity would be, let's split up this little fraction. Cos squared over cos squared is 1 plus sine squared over cos squared. Sine over cos is tan. So we've got secant squared equals 1 plus tan squared. We used derivatives to find a new identity. This is one of those regular identities. You could actually take the regular identity sine squared plus cos squared equals 1, and you can get quite a few identities from it. All you have to do is just divide by one thing and see what you get. Divide by another thing and see what you get. So instead of memorizing this identity, why don't you just start with this identity and divide by cosine? Look, if I just divide by cos, we get sine squared over cos squared plus 1 equals 1 over cos squared. Well, we know this is secant squared, and this is tan squared. Okay, what if we divide by sine squared? Well, we've got 1 plus cosine over sine is cotan now, or 1 over tan, however you want to say it, or cotan squared x equals, well, 1 over sine plus cotan squared x. 1 over sine is 1 over cosecant. So cosecant squared x. So instead of memorizing different identities, memorize one identity and get to the rest from it. Okay. Let's see. Let's see, what should we do? We did some product rule. Let's do some chain rule. Definition of chain rule. And then maybe if nobody's got any stuff they want to do, I will do some of my stuff. It won't be very talkative, but I'll just do some of my stuff. chain rule. And this will actually work out perfect in tandem, because then we'll do vector calc. In which case, I'm actually working on chain rule as the next unit. So, do that. So, dy dx, okay, dy dx is the same as saying d by du, or dy du du dx. Because there is a difference in rates of change. So let's say y changes, but also you've got a composition function, let's say. FOC, which is you've got some function of x, let's say, and you've got some function c of t, and the composition of them, you want to find the derivative of f with respect to t. So this would be f of c of, oops, c of t, which means c of t is replaced for x. So if you had, let's say, f of x is x squared, pretty simple one, and c of t is x plus 1. Or no, t. Thinking of wrong variables here. T plus 1. Well, now you want to differentiate f with respect to t. What do? You plug in the c of t function into f. You've got everywhere that there is an x equals t plus 1. Now you plug in t plus 1 for x. So we've got f of c of t is equal to t plus 1 squared. And now we want to differentiate this with respect to t. This gives us 2 t plus 1. Okay. Now, the formal definition is the chain rule. If g is differentiable and f differentiable, I'm going to say at x at g of x, then the composition f, capital F, is equal to FOG defined by f of x is equal to small f g of x is differentiable of x and given by f prime of x equals to f prime of g of x times g prime of x. Okay. In other notations, you could say dy dx is equal to dy du times du dx. And u would be like the other function inside the function. Okay. How do we use it? let's use it with this this new notation first. So we've got let's see, a question. U equals to x squared plus 1 and y equals the square root of u. Then we'll use this notation first, so dy dx, but there's no x here, it's a u, equals dy du times du dx. So we should find these separate ones. So what's the derivative of y? dy with respect to u. So u is the variable we're going to differentiate. So what is, I'm going to say u to the 1/2 prime. So what is the u to the 1/2 prime? So dy du, well, it's just the power rule. Bring the 1/2 down, subtract 1 from the exponent. This is 1/2, and then I'm just going to write it square root of u. Okay, what is du dx? Derivative of u now with respect to x, so this is just x squared to plus 1 prime. So du dx is equal to, well, derivative of x squared is just 2x. The derivative of a constant is 0. So we just got 2x. Now, plug it back in. dy dx is dy du, which is 1/2 to the square root of u, times du dx, which is 2x. But we want it in terms of x, not in terms of u. We have to, everywhere there's a u, we plug in the function. Now we've got dy dx equals 2x over 2 square root of x squared plus 1. Cancel out the 2's, which gives us x over the square root of x squared plus 1. Just like that. Cool. If we combine, yeah, alpha path, what do you want to do? What are you working on? Better yet, what year are you? Also, you can help me with the delay on YouTube. I'm not sure what it is. Geometry. Okay, what kind of stuff on geometry? Like, are you doing high school geometry? like if you really wanted to, you could send me a picture of your homework, something that you're working on, and then I can go from there and try and figure out what it is that you're having trouble with, or just relevant to your topic. Is that something that would be interesting for you? Or if you don't want to send me an email, I mean, you could always send me a picture on Discord or on Instagram, Twitter, however you want to do it. Y segment Y0. Ys is 5x minus 2, Y0 is 6x plus 10, x equals. Find the missing measure of if S is the midpoint. Interesting. Okay. So we've got a line. Is there a picture that goes along with this? Is it a triangle? Find the missing measure if S is the midpoint of the line segment Y0. Okay. Here's Y, here's O. Unless that's meant to be the origin. I'm not sure. S is the midpoint. So we'll say that's the midpoint. Okay. So the whole thing. Cool. Cool. Y. Okay. So Y to S is 5x minus 2. Okay. And Y to 0. So this is this segment here. Y to 0, or Y to O, the origin, however you want to say it, is 6x plus 10. Okay. What other information were we given? Something that it's kind of missed at the beginning, but it's in there. I want you to tell me what other piece of information is there that we're missing. There's one more piece. No. Think about, there's a word in there. Midpoint. What does midpoint mean? Okay. Midpoint. Middle of the line segment. Exactly. What does that mean? That means that this line here, so Y to S, is equal to S to O. Okay. And we know that YS plus SO is equal to YO. Did you see that? Because this line segment is equal to this line segment, and it adds together to be the whole line segment. Now we should be able to finally solve the equation. These two are the same, which means we could say 2 times ys is equal to yo, which then, we've got some formulas here. 2 times ys is 2 times 5x minus 2, and this is equal to the whole segment y0, which is what? 6x plus 10. See that? Hey Alpha, tell me what to do next. Good, 10x minus 4, you got it. And this will be what, 6x plus 10 still? We'll take the 6 to the other side. So tell me what you get. Since there's a bit of a delay, I get to do this. 10x minus 6 is 4x. Plus 4 to the both sides gives us 14. Divide by 4. 14 over 4, which is 2 times 7 over 2 times 2. 2's cancel out. Good. 7 over 2. Let's think, does it work? Does it work? How would we know if it works? 6x plus 10 is the whole line segment, and 5x minus 2 is half of the line segment. So let's plug in 7 over 2. So if half of the line segment is 5 times 7 over 2 minus 2, does this number times 2 equal 6x plus 10? That's okay. Alpha, if you have any other problems with your homework throughout the year, you can go ahead and let me know. We can do this stuff whenever you want. Just send me a message on Twitter, Instagram. If I'm on here, just come join the chat. Random Pigs, did I upgrade my hardware? I haven't really. I've got, like, if you saw my first stream last year, I had just the whiteboard, and since then I've got this drawing tablet which works wonders, and it's a great thing. Plus I've been using Photoshop, and I've been designing my own things that I do. Random Pigs, if you check my Instagram, I've been making things to post, little questions and whatnot. It's worked out okay. Alpha, thank you for subbing. I appreciate it. If you tell other people, that's even better. This is good stuff. Good stuff. Okay, what else can we work on? It's easier when there's more people and they have problems, because then we just go through their problems one after another. Now I have to make some stuff up again. All right, Alpha, that's okay. If you were one and done, that's good enough. Just solve AMC 12 problems while we wait. The AMC 12 problems, is that the Millennium problems? AMC 12 is high school math? Okay. Well, I've got I'm just actually looking up AMC. Look at that. Neat. Okay, I'm gonna look into this stuff. Very hard high school math. Well, does it have to be hard? Lots of times people just have problems doing the easy problems. Alpha, in case you're wondering, I actually have 2 streams going right now, one to YouTube and one to Twitch. Questions 20 to 25 get ridiculous. Is it worth it though? I'll do some grade 12 stuff. We don't need to do more calculus. Let's do some grade 12 stuff. Thankfully, I bought textbooks for all of high school, and high school here is like grade 9 to grade 12. I've got first year calculus, got some differential equation stuff ready, but it's all mostly just the beginner stuff to get people rolling and understand basic concepts. And then that's stuff I can just do in the meantime. Like, if I scroll up, way up to the very beginning when I started today, if it'll let me, there we go. We started with a division integral problem. All right, Alpha, you have a good time. I'll see you next time. Let me know anytime you need problems. We did some interesting integrals to begin with. Then we worked on, what did we do? More partial fractions that involved natural logs. We did derivative of sine with limits. What else did we do? Some product rule questions, find an equation of a tangent line. What else? The other day I was doing absolute values for a while. I got a kid that wants to be tutored, but he doesn't want it to be live, so I'll have to end the stream pretty quick here, I think, when he's ready. And then I'll have to turn it on back again later. So I think I'll end the stream in about 10 minutes. Since it's just around 6. And that way it'll give me time to tutor and get some dinner. And then we'll turn it back on again later. Probably about 2 or 3 hours after that. So maybe we'll do a late night stream. I'd like to do earlier in the day, but there's so few people that need help earlier in the day since university hasn't really started. And that's when people would be doing calculus. So after school, high school time, right? Okay, grade 12. Pre-calc. This is what I've got. This was the textbook that was on my Western Canadian list of textbooks that high school people are using. So, radical functions and transformations is the second chapter. I think that's what we're on. Graphing radical functions. Okay, graphing radical functions. Ugh. Graph each function using a table of values, then identify the domain and range. So, do kids know table of values? So, what is our function? Y equals the square root of x minus 1. I personally don't like the way kids are introduced to functions. Because they're introduced to a function, and then they go through a whole formula, and they're introduced to another function and introduced to a whole formula. If they learn the basics of just taking any function and changing it around, they can apply that to everything they learn later. Now, in this textbook right now, for practicing and checking your understanding, they want a table of values. Y equals an x. So when, let's do x is negative 1, x is 0, x is 1, and 2. When x is negative 1, well, that doesn't seem to work, right? It's undetermined. Because this would be negative, a negative 2, negative under the square root. It's finicky. It doesn't work. Undetermined. Or no value. When it's 0, we still get a negative 1, and it's undetermined. When we get 1, we get 0, and 2 minus 1 is, well, 1. If it's, let's say, 5 will be a good value. Then 5 minus 1 is 4. The square root of 4 is 2. So now they want us to quickly graph. Here's our y, here's our x. When x is 1, y is 0. When x is 2, y is 1, we'll say it's about there. And when x is 5, it's about there. Somewhere looking like that. Now, in this one, it doesn't look like they're incorporating both sides. No, it doesn't. Just that. Now, this is a little strange to me because what if we do this in reverse? we've got y equals square root of x minus 1. And let's say we square both sides, so we get y squared equals x minus 1. And we change this to be x equals y squared plus 1. Well, what's the graph of that? Well, now x is equal to y squared and plus 1. So if we add a 1, and look, it's a parabola with a similar shape going this way. Interesting. How come this textbook didn't do that? They only wanted the upper side. They didn't want to show the relation? I'm not sure. There was a question in here as I was flipping that seems pretty nice, because now we have to apply what they've learned. And it's interesting because they're doing transformations, but they're not talking about in general transformations. They're going through it in each formula. So this is 1/4 square root of x. Identify the transformations represented by f of x as compared to. So basically, what is the transformations? Well, we've noticed this part. We've got a 1/4 times our f of x. And we've got f of 5x. What do these do? Well, let's think about it. Originally, if you have a value, let's say it's 1, you multiply it by 1/4, well, it shrinks it. And it shrinks all its values. So that would shrink the verticality of it. It would shrink. Vertical shrink. Okay. Now, if every value you plugged in, x, became, hey, Trey the Trainer, thank you for the host, bud. You weren't even just streaming, were you? You just came to pop by. It's just unfortunate because I'll have to end the stream soon to go tutor a kid privately, and then I'll have to come back later. That's okay though. Okay, f of x. People need this info. Yeah, it would be really nice. What does plugging in 5x for x? You'll be streaming later? Okay, I'll come check you out too, bud. It would be really nice if the kid I was going to tutor wanted to do it on stream, because then I could just continue going, but I guess it's okay to take a break. I should probably turn on my Xbox and get a couple games that you guys play and maybe join you sometime. I'm not much of a Fortnite person though. Okay, what does this transformation do? Okay, let's think about it in terms of another function. Let's do y equals x squared. If we plug in 5x for x squared, well, you get a little bit of a change. This would be increasing the value that you plugged in. And it would be increasing it by quite a bit. So it looks like it would be a horizontal stretch. So and I think I did a post on this, didn't I? I did, didn't I? Function shifts. Stretching. This right here is what we're doing. I think I used the wrong word. I did. Horizontal compression. Because when you think about it, right in here, the y value is stretching up. So the horizontal is compressing. Or you may think vertically stretching. Vertically stretching. Okay. What do they want you to write in this question? What is the transformations? Well, we got a shrink and a horizontal compress. If we wanted to. Okay, bud. What are you taking anyways? Trey, what are you taking? Like, it sounded like you weren't in first year. Or are you? You can't be. Let's see. 2.1. Intermediate algebra? What's intermediate algebra? Like, it's a college course, right? But it's not calculus. Wouldn't be differential equations. So is it like a catch-up course? Would it be linear algebra? Linear algebra would be the matrices. Okay. Okay. Trey, you tell me. Dude, send me your curriculum when you get it. Okay, good, good. Seriously, Trey, throw me your curriculum when you get it, and I'll take a look and see what I can put together for you, even. Because there might be some things that you may need to know that you don't know, and that your teachers won't go through. Because I find a lot in school, kids will forget the small details of, like, what is multiplying by a fraction do, or something like that. Oh, Trey, at the very beginning, a pure example of things that you forget to do. You see this right here? You would not remember how to do division, long division, if you hadn't done it in years. And you needed to do long division in a course. Nice, bud. Nice. I need my green screen picked up back. I prefer it more than just this little camera screen. I don't have enough space in this place though. Okay. Okay. Where were we? All the way down here. Okay. Write two functions equivalent to f of x. One of the four... Oh, okay. B. Two functions. Write two new functions. That are equivalent to this first one. I see what they did here. One-fourth square root of 5x. Nice. Okay, great, Trey. I hope you have a good workout. I should probably do that too soon. I didn't do my run this morning because it was raining. Oh, and Raj is ready. So it looks like I'll have to end now too anyways. I'll do this first and then we'll end. Okay, write two functions equivalent to it. One has to be y equals a root x. And the other one has to be y equals the square root of bx. Okay. Well, this is just using our radical rules. Like radical, dude. You know those? Radical rules. So the square root of AB equals the square root of A times the square root of B. And that's it. So we've got 1/4 root 5x. Have fun, Trey. Thanks for the host anyways. Thanks for bringing people in. I much appreciate it. I'll see you later. I'll come talk to you on your stream. Okay. We can say that we want to bring the 1/4 inside. We're going to go just like this. When we bring the 1/4 inside, we'd have to square it so that the square times the square root will cancel each other out. So 4 squared is 16. 16 times 5x. So we get 5 over 16x under the square root. That's equivalent. What about... so that was this version. And what about taking the 5 out? Same thing. Square root of 5 over 4 times the square root of x. This is our a, and it's a constant. We're done. All right. I have to finish for now, and we will let's find somebody to host as well. Who should we host? Let's get a small one here. Let's see. All right, people. I will catch you guys later. I'm gonna probably be about 6:15 now. let's say 2 hours and 15 minutes. We'll try for 8:30, but at latest we'll try for 9. Catch you guys later.